Hi, we're going to talk about quadratic functions. Today I'm going to explain you how to tell the form of a quadratic function, and if you don't have any material to do a graph, you can use this information to sketch a quadratic function. If you have the information, it's going to help you to understand whether your graph is good, is correct or not. So first, let me tell you some properties about the quadratic functions. A quadratic function is a function of the form f of x equals ax squared plus bx plus c, where a, b, and z are real numbers and a is different than 0. Of course, if a is 0, so this term will be a linear function. So obviously it's not going to be a quadratic equation. Now, the larger a is, the narrower the graph is, and the smaller the value is, the wider the graph is. So let me show you this with a graph. Does it mean narrower and wider? So we're going to start doing the graph with positive x squared. So you could see here x squared, positive. Now we're going to increase the value of a. So for example, 5x squared. So this is the narrower the graph is. So what if I wrote y equals x squared divided 2, 1/2 of x squared. So we have wider and narrower. This is what means when we say narrower the graph is, or the smaller or wider the graph is. Now the graph opens up if a greater than 0 and downs if a less than 0. So we can see here what happens if a is greater than 0. So I'm going to erase this 2. And we're going to use y equals minus x squared. Okay, a is negative, less than 0. So you could see that opens up if positive a plus 1 and opens down if a less than 0. Now, quadratic equation has an axis of symmetry in the vertical line x equals h. So in this example, the axis of symmetry is at the line x equals 0. Let's graph another quadratic equation. For example, y equals 2x squared minus 3x plus 1. So as you can see this graph, let's erase the other 2. As you can see this graph, the axis of symmetry is not at x equals 0. It will be here, x 0.8 or 0.9. Okay, so this is the difference between the axis of symmetry. It changes according to the quadratic function. For example, if I wrote another quadratic function, x squared plus 2x plus 2, the axis of symmetry change. Now the axis of symmetry is kind of 1. near to 1. Now, quadratic equation has a vertex on H and FH. This is the point. Oh, what is this point? This point is exactly in the line of symmetry. Okay, this point in this case is the minimum point of the function, and if A is negative would be the maximum position of the function. So this is the vertex of a parabol or the vertex of a quadratic function. And to find the intercepts, you can use factoring if you like, or use the quadratic formula. This is the quadratic formula. Quadratic formula is going to show you positive or negative. That means that quadratic equations could have more than one intercept. If we look here to this graph, x squared plus 2x plus 2, there's no intercepts. There's no intercepts. And here we have two intercepts. There are no intercepts because of something calling the discriminant of the quadratic function, of the quadratic formula. This is the discriminant. Okay? If the discriminant is greater than 0, I like to call this information D. D b squared minus 4ac. If D greater than 0, there are two intercepts. Two x intercepts. Okay? X intercepts. If D equals 0, there is one x intercept. And if D less than 0, there are no x intercepts. Okay, so discriminant is going to tell you if you have in your quadratic equation 0, 1, or 2 intercepts. I can tell you without calculating the discriminant that the discriminant of this of the quadratic equation that corresponds to the intercepts of this quadratic function will be greater than 0. Less than 0, because there are no intercepts. And for this equation, this quadratic function, if we determine the intercepts using the quadratic formula, we could have two intercepts. It means D is greater than 0. Okay? So this is the theory we need. Now, let me show you how to determine the vertex of a quadratic function using some steps that are easy to understand. What are we going to do? We're going to try to express this function in such a way that we have the function ax squared plus b. Why ax squared plus b? Here we could watch that the function x squared, 2x, anything, has its vertex here. Now what happens if I increase? So the vertex is at the line x equals 0. What happens if I increase x plus 1? Look at, I move to the line x minus 0, x minus 1, excuse me, x minus 1. What if I change the the function and write 2x plus 1. Oh, excuse me, I wrote the same. What if I change the function and put x minus 1? I'm gonna move it to the line. The axis of symmetry will be x equals 1. So here is the vertex. The vertex is x equals 1 and the vertex is x equals 0. And let me show you another part. So we're using x minus 1 and I'm going to add here 3 units. Look at the vertex now is 1 and 3. 1 and 3. So this is one way to determine the vertex, by doing something in such a way that this function will be of the form x squared, x plus something to the second power plus a number. So how could we do that? We can do it by applying the perfect square trinomial. Perfect square trinomial. So first I'm going to factor a. I'm going to factor a. So if I factor a, okay, I'm just going to factor a here for the first two terms. Two terms. Okay, we have here, we're going to factor a. So if I factor a, will be, if I multiply it, I will have ax squared plus bx. No, we need to have bx when we multiply. So we can have here b divided ax. Okay? Now, we have to add here a term that helps us to get a perfect square trinomial. So what will be this term? You have x squared plus b over ax. So we have to add some term in such a way that we have a perfect square trinomial. Remember that perfect square trinomial is of the form let me write it, a plus b to the second power is a squared plus 2ab plus b squared. So here you could see that we have x squared, a will be x, a will be x. So b divided a is 2b. So if b divided a is 2b, it means that b is one half of BA, yeah? 1/2 of BA. 1/2 of BA. And we gotta write it to the second power. So we got to write b to the second power divided for a to the second power. So let's check. If I get the root of b squared divided 4a squared, I will have b divided 2a times 2 b divided a times x, b divided a times x. So we have the perfect square trinomial. But remember that if you add, you have to subtract because you need the same equation. You need the same equation. Okay, so far what we did, we just factor a, then we complete the perfect square trinomial using the equation, and we subtract the term that we use to complete the perfect square trinomial. If you notice, this term is 0, so we're not changing the equation. Now, applying the perfect square trinomial, we have that this term is x plus the root of this part b divided 2a minus b squared divided 4a squared, and to the second power, of course. Okay, and now I'm going to multiply out the a to each factor because I want it in the form ax squared plus another thing. So first, I can multiply a here, but there's an a as denominator, so we can just simplify, and this is the form a times x plus something to the second power minus b squared divided 4a plus c. Okay, now as you could notice, we just get the vertex. This will be h, or in fact this is minus h, as we could see using the functions, and this will be the point that you're using as the vertex point. So to sum up, the vertex is in the point it says here that the point is h and the function evaluated in h. But now, using graph functions, using information, we notice that this is minus h, so the point is minus b divided 2a, comma, and this is the other part. Okay, if you don't like negative numbers here, we can write it after z minus b squared divided 4a. And this is how you determine the vertex. You just have to apply this formula here and you have the vertex all time. Now, we're going to tell the form of quadratic functions using the information that we have seen. We're going to watch some examples. Example number 1. Tell the form of the quadratic function. Okay, first, I want to know which one is a, b, and c. So a is minus 3, b is 6, and c is 1. Okay? Now, as a is negative, the function opens down. The function opens down. Remember, opens down. So opens down. So I'm showing you with my mouse. Now, next. The next part is to determine the intercepts or the vertex. So the vertex. Calculate the vertex. So h is minus b divided to a. So is minus b is 6 divided 2 times a minus 3. Okay, we don't have to be an expert in algebra to know that minus 3 times 2 is minus 6, and minus 6 divided minus 6 is 1. And z minus b squared divided 4a. So we have z 1 minus b squared, 6 times 6 to the second power is 36, 4 times a minus 3. So 4 minus 3 is minus 12, and 36 divided minus 12 is 3. So we have 4. So vertex is on or at on 1 and 4. I gotta tell you something. I know that as my vertex is on 1 and 4 and a is negative, it means up and down, we can see that the function should have two intercepts. So finding intercepts. I'm gonna try to find the intercepts, finding x-intercepts. Okay, some people will ask why I'm trying to find x-intercepts and no y-intercept. Okay, y-intercept is with x equals 0, so z is the y-intercept. So y-intercept is 1. And finding the x-intercepts, we just gotta set this equation equals to 0. Okay, I'm gonna apply factoring to find the intercepts. Remember, if factoring doesn't work for you, so you can apply the quadratic formula. So let's multiply by negative all the equation to have 3x minus 6x minus 1. This is a trinomial of the form ax squared minus plus bx plus c. So I'm gonna apply the method. I'm gonna explain it here. We need to use another video to explain it. I'm just going to apply it. So 3 times minus 1 is minus 3. Minus 3. And I need two numbers whose product is minus 3 and whose addition is minus 6. Okay, we don't have these numbers. We don't have a number whose product is minus 3 and whose addition is minus 6. So we cannot do it by factoring. So use quadratic formula. Okay. Use quadratic formula. b squared minus 4ac is the discriminant. And look at that b squared and 4a is here. Yeah. So d from discriminant, d equals b squared minus 4ac is b squared. So 36 minus 4 times minus 3 times z, that is 1. So we have 36 plus 12, 46, 47, 48. D is 48. So D is 48. We have the square root of 48. And minus B, we saw that is 6. And okay, I'm using the actual equation with a negative. So I'm going to erase that. We're using this. A minus 3, B 6, and x 1. B is 6. And 2 times A will be 2 times minus 3. Okay? You can simplify 48. You can simplify 48 to check some way to get more information. First, let me show you that minus 3 times 2 is minus 6. Is minus 6. So we can simplify this minus 6 here, or split the fraction to have 1, then positive and negative, and here we have 6. Okay, I split the fraction, so we have minus 6 divided minus 6, positive and negative, and the other fraction is root of 48 divided minus 6. Okay, but as positive and negative is just giving you two options, the minus 6 could be here, could be negative, positive, but there's no any complication to have positive, negative. And let me use properties of roots to simplify 48. 48, I can write 48 as we can write 48 as 24 times 2. Or as 12 times 4. Okay, or as 6 times 8, or as 3 times 16. Yeah, and the square root of 16 is 4, so we can write it as 4 square root of 3 divided 6, and we can simplify the 4 with a 6 using 2/3 of the square root of 3. So this is the final option to have the intercept. We have one intercept at 1 plus 2 square root of 3 divided 3, and the other at 1 minus 2 square root of 3 divided 3. Okay, these are the points of intersection with the x-axis. So what do we have now? If you don't have any idea how the function is, you know already that the y-intercept is at 1. So here is going to pass by here. You know that the x-intercepts are 1 plus 2 square root of 3 divided 3. You may use your calculator to check the actual value. So it will be here, one of them, and the other should be like here. And you will note that the point of intersect of the vertex is at 1, 4. 1, 4. So 1, 4. 1, 4. Let me erase the graphs. When did you check the graphs? 1 and 4 here. So one, 4. This is the vertex. So the other point, the points of intersection are x0, 0, and y is 1. This is the other point of intersection. Okay. The other point is for y equals 0. We say that is 1 plus 2 times square root of 3 divided 3, and the other point of intersection is y0, and here is 1 minus 2 times square root of 3 divided 3. Okay, so these are the points. So using these 4 points and knowing that the function is of this form, you just have to make a line using the quadratic formula information. So obviously I have here a program. I can do the graph and check it, but maybe you have graph paper, or you don't have a program, you don't have some way to graph, so you need to know first the points. You graph the points and then you check the equation. I'm going to show you the equation. Minus 3x squared plus 6x plus 1. So y equals minus 3x squared plus 6x plus 1. Okay? You could see the graph passes by the points that I just selected. This is the way you can sketch graphs before doing the graph. I did the graph because I have here a program to do the graph, but if you don't have the program, you can set the points using algebra and then do the graph. And I hope that you understand how to find the graphs. I'm going to tell you something. One way to understand, if you understand, is that you practice. So I'm going to tell you something. Why don't you practice to tell the form of the quadratic function x squared minus 6x plus 9. Pause the video, try to do it, check it, the other parts of the video, and after you did it, check it again the video until finishes, then I'm gonna show you the graph of the second function. So pause the video. Okay, I hope that you pause the video, you try to do the exercise, you did your best, because I'm gonna show you now. So let's see the steps. It says check A, B, and C. So I'm going to check A, in this case is 1, B is -6, and C is 9. Now, is 1 positive? So the function opens up. Now, I know that this is the form of the function. In this case, it's not this form, but the other form. Now, you know that the y-intercept is 9. So we can go to the program and tell them, okay, program, give me a point in 4x equals okay, it doesn't work. Okay. Okay. So let's put a point in 0, 9. Okay, this is the first point. Next, now calculate the vertex. So vertex, so we said that the vertex is minus b divided 2a. So b is -6 divided 2a, 2 times 1. Okay, so h is 3. And the other point of the vertex is z minus b squared divided 4a. So z is 9 minus b squared is 36 divided 4 times a, that is 1. So we have 9 minus 9, 36 divided 4 is 9, 0. So the vertex point is 3, 0. Let's put the point. So the point is at 3, 0. Okay, I'm getting a new point now. 3, 0. And let's see the points of intersection. The points of intersection. So finding x-intercepts. Okay, I'm gonna tell you something. As I know that the vertex point is 3, 0 is one of the intercepts, I know already that I just have one intercept because the vertex point is the maximum or the minimum point. But we're gonna check it. We're gonna check it actually to know that it's true, that is completely true. How could I check it? So we're gonna say that the equation is 0. And we can use factoring. You can use factoring to check. So could you notice that this is a quadratic formula? 3 to the second power is b. 3 will be b. 3 times 2 is here. So actually this is a perfect square trinomial. X minus 3 to the second power. So if you use the zero factor property, using zero factor property, we have that each factor should be 0. The factor is the same, so we have x minus 3 equal to 0, so x equals 3. 1 point of intersection. So we just have 1 point of intersection, and we just have a symmetry axis is here. So how could you draw the quadratic function? You can draw the quadratic function in this form using these points, using the form of the quadratic function, and use the symmetry axis, this is the symmetry axis, to draw the other part. Okay, if you're sketching functions, it's not completely needed to be in all the points, just getting the important points like the vertex and the points of intersection. So we're just going to do the graph here for you to check that we are in the right place with the points. So y equals x squared minus 6x plus 9. Okay, good. We have here passes by the 2 points. And this is how you can tell the form of quadratic functions, and this is why you can sketch quadratic functions. I hope that you enjoyed the video, and remember, if you have any questions, let me know. If you have any hint, let me know. If you have some corrections that we have to make to this video, let me know. I hope that you enjoyed the video. Thank you. Goodbye.